What if the deepest truth about your life is already out there, waiting in silence between the stars, but you are just not looking far enough? There is a strange feeling humans carry inside them, a quiet pressure, a sense that something bigger is calling, but never clearly speaking. It feels like standing in the middle of a dark ocean, knowing there is land somewhere, but never seeing it. This is the same feeling scientists get when they look into space. And recently, that feeling became even stronger when the James Webb Space Telescope turned its attention toward one of the closest star systems to Earth. Not because it was simple, but because it was not. Out there, just 437 light years away, lies Alpha Centauri. In cosmic terms, it is our neighbor. In human terms, it is unreachable. Even if you spent your entire life moving toward it, you would never arrive. That alone changes something inside the mind. It forces a question most people avoid. If something so close is still so far, then what else is beyond your reach that you have not even imagined yet? This is where the universe becomes uncomfortable, not because it is hostile, but because it refuses to match human expectations. We live in a world where we want speed, fast answers, fast success, fast transformation. But space does not obey urgency. It moves in silence, in patience, in scales that erase human impatience completely. Light itself takes years to travel. That means every glimpse we get from distant systems is already history, already gone, already decided. And yet, the James Webb Space Telescope continues to collect that ancient light. It does not rush. It does not guess. It waits. It listens. It absorbs what the universe has already written long before humans learned how to read it. And in that waiting, there is a lesson most people miss in their own lives. Progress is not loud. Growth is not instant. And truth does not appear just because you are desperate for it. When scientists pointed their focus toward Alpha Centauri, they were not expecting magic. They were expecting data, simple patterns, familiar signals, things that fit inside known science. But space rarely stays inside expectations. That is its nature. It expands beyond every boundary we create. It reminds us that certainty is often an illusion built to make us feel safe. And maybe that is why people feel drawn to space in the first place. Because deep down, they already know life is bigger than their current understanding. They just do not know how to face that truth without fear. Think about your own life for a moment. There are goals you can see clearly, and there are goals that feel like distant stars. You know they exist, but the distance makes them feel unreal. You start to question yourself. You start to doubt whether you are even capable of reaching them. But the universe does not measure distance the way fear does. Fear says far means impossible. Space says far simply means time. Alpha Centauri does not change its position because it is far from Earth. It simply exists, constant, silent, unshaken. And that stability is powerful because it reflects something important about you too. The things you are meant for do not disappear just because they are not close yet. They remain, waiting for the right moment, the right growth, the right version of you. This is where the human mind begins to split. One part wants comfort. The other part wants expansion. One part wants to stay where everything is familiar. The other part feels pulled towards something greater, even if it is unclear and uncomfortable. This conflict is not weakness. It is evolution trying to happen inside you. The universe has always worked like this. It pulls matter together. It creates pressure. It forms stars from collapsing chaos. Even black holes are not symbols of destruction alone. They are reminders that intense pressure can reshape reality itself. So when your life feels heavy, when your direction feels unclear, when your future feels like it is collapsing inward, it may not be an ending. It may be formation. Because every star begins in darkness, and every system like Alpha Centauri carries that same truth. Creation does not happen in comfort. It happens in pressure, distance, and time. This is what makes the recent focus on Alpha Centauri so powerful. It is not just about what the telescope sees, it is about what it forces humanity to feel. Smallness, yes, but also potential. Because if we can observe something so far away, then we are not limited by where we stand. We are limited only by how far we are willing to think. And that is the hidden reward of the story. If you stay with it, if you let it settle inside your mind, you start to realize something important. The universe is not just showing you distant stars, it is showing you your own mind from a higher angle. It is revealing how much of your potential is still unactivated, still unexplored, still waiting in silence. So the real question is not what the telescope found. The real question is what you will find when you finally stop thinking in small distances and start thinking in cosmic scale, because somewhere inside that shift, your life begins to change. The moment perception expands, something subtle begins to shift in how reality is understood. What once felt like a simple measure of space starts to behave more like a distortion of information. Distance is no longer just a gap between objects. It becomes a delay in knowledge, a lag between existence and awareness. And this is where human intuition begins to struggle. Because the brain is not built to naturally process time stretched across cosmic scales. In everyday life, people assume what they see is current. A face, a building, a moving object all feel immediate. But in the deeper structure of the universe, nothing is truly now. Every observation is an arrival of old information. Even the most advanced instruments, including the James Webb Space Telescope, are not viewing present reality. They are decoding ancient transmissions that have survived a long journey through expanding space. What appears as distance is actually accumulated time waiting to be interpreted. This is where understanding begins to break conventional thinking. When humans say something is far away, they often translate it as unreachable. But in cosmic mechanics, far simply means delayed. The information is still there, but it arrives later than expected, like a message sent through a system that cannot deliver instantly. Nothing is missing. It is only traveling under constraints that the human mind rarely considers. At the same time, space itself is not static. It stretches, bends, and shifts the path of information. Light does not travel through an empty void in a straight, simple way. It passes through regions influenced by gravity, radiation fields, and structural expansion of space-time. Every photon carries a history of its journey, shaped by conditions most people never think about. By the time it reaches a detector, it is no longer just light. It is compressed memory of an entire pathway across reality. This is why systems like Alpha Centauri are not experienced directly. They are reconstructed through fragments of signal, each one slightly altered by time and environment. What scientists interpret is not a direct view, but a structured reconstruction of something that has already changed since it sent its signal. This creates a strange truth. Observation is always behind existence. And yet the human brain resists this idea. It prefers immediacy. It prefers alignment between action and result. When that alignment breaks, doubt appears. People begin to think progress is not happening simply because it is not visible yet. But visibility and reality are not the same thing. There is a hidden delay between effort and evidence, just as there is between emission and reception in space. This delay can be described as a kind of cognitive compression limit. The mind can only process so much uncertainty before it tries to simplify it into either success or failure. But the universe does not operate in binary outcomes. It operates in layers of gradual emergence. Signals build slowly, patterns form over long periods. Meaning becomes clear only after enough fragments align. Even background radiation that fills space is not random noise. It is structured information left over from early cosmic phases, stretched and cooled over unimaginable spans. What appears as emptiness is actually residual data spread thin across expansion. The universe never deletes its past. It only disperses it until interpretation becomes difficult. Human thinking, however, often deletes its own potential too early. When results are not immediate, conclusions are formed prematurely. This is where most growth collapses, not from lack of ability, but from misreading delay as absence. The same error would occur if a signal took years to arrive and was judged as silence simply because it had not yet reached its destination. There is also a deeper layer to this misunderstanding. Perception itself is bound by processing speed. Neural systems interpret reality through sequential updates, not simultaneous awareness. This means experience is always slightly behind what actually exists. Even the thought forming in the mind is already a fraction of time old by the moment it is recognized. When this is applied to ambition, the implication becomes powerful. Every effort made towards something meaningful already exists in motion, even if the result has not arrived within awareness. The gap between action and outcome is not emptiness. It is transit. But because the brain cannot directly observe transit at cosmic scale, it interprets it as nothing happening at all. In advanced observation systems like the James Webb Space Telescope, engineers constantly deal with signal noise, distortion, and latency. They do not assume absence when data is unclear. They refine, filter, and recalibrate until hidden structure becomes visible. This is not just a technical process. It is a model of thinking that most human minds rarely apply to their own lives. Because in personal experience, noise is often treated as failure. Delay is treated as rejection. Uncertainty is treated as lack of direction. But in reality, these are just layers that have not yet been resolved into clarity. The structure is still forming beneath interpretation. It simply requires continued observation without premature closure. When applied inwardly, this understanding changes how effort is experienced. It removes the illusion that nothing is happening. It replaces it with the recognition that everything is in motion, even when results are not visible. Just as light continues its journey long after it leaves its source, human effort continues its trajectory long after it feels unnoticed. And this is where the mind begins to expand beyond its usual boundaries. Because once delay is no longer mistaken for emptiness, patience becomes something else entirely. Not waiting, not hoping, but understanding that reality is always arriving later than it is created. The deeper implication is unsettling at first, but liberating after reflection. What feels like distance in life may not be distance at all. It may be information still in transit, still unfolding, still approaching awareness. And if that is true, then nothing meaningful is ever truly lost. It is only not yet fully received. This shift in interpretation quietly prepares the mind for what comes next. Because once the illusion of nothing happening dissolves, attention begins to focus on what is actually being revealed underneath the delay. Once the mind accepts that nothing is truly absent, only gradually revealed, a different kind of tension begins to surface. It is no longer about waiting for results. It becomes about interpreting what the results are trying to become. Because when raw data finally arrives from deep space, it rarely speaks in clear language. It arrives fragmented, layered, and partially incomplete, demanding patience that goes beyond expectation. When instruments like the James Webb Space Telescope collect light from distant regions, they are not receiving simple messages. They are receiving overlapping traces of physical events that have already transformed multiple times before reaching observation. Each fragment carries compression from gravity, motion, and cosmic scattering. What reaches analysis is not a clean picture, but a structure that must be carefully reconstructed through inference and comparison. This is where interpretation becomes more powerful than observation itself, because observation alone is never enough. It must be shaped into meaning through layers of reasoning, and meaning is not given directly by the universe. It is extracted through persistence. When scientists directed attention toward Alpha Centauri, they were not searching for simplicity, they were searching for consistency, familiar patterns that align with known stellar behavior. But what emerged from early examination was not a straightforward match to expectation. Instead, there were subtle irregularities embedded within the collected signatures, not dramatic enough to declare discovery, not weak enough to ignore, something in between where certainty struggles to settle. This in between state is where most scientific breakthroughs begin, but it is also where most assumptions collapse. Because the human mind prefers alignment. It prefers clear classification. It wants to label something as either understood or unknown. But nature rarely respects that division. It exists in gradients, where truth is distributed across probabilities rather than fixed points. In the incoming data sets, there were variations that required repeated verification, slight shifts in intensity, unexpected alignment in spectral components, timing differences that did not fully match initial models. None of these elements alone confirmed anything unusual, but together they created a tension in interpretation that could not be dismissed easily. This is similar to how intuition works in human life. A single event rarely changes perception, but a pattern of subtle signals builds internal pressure until awareness begins to question its own assumptions. The same mechanism applies when scientists study cosmic structures. Meaning is not found in one moment. It accumulates across repeated exposure to inconsistency. There is also a deeper challenge hidden inside this process. Measurement tools are designed based on existing knowledge. That means they are inherently limited by what is already understood. When something lies outside that framework, it does not immediately appear as new truth. It often appears as error, or noise, or statistical deviation. And this is where many unknowns are temporarily pushed aside until further confirmation becomes possible. But space does not organize itself according to human categories. It does not separate clarity from confusion. It produces both simultaneously. What appears as disorder from one perspective can contain hidden structure from another scale of analysis. Like galaxies forming intricate spiral systems out of gravitational instability, what looks chaotic at first can resolve into elegant organization once the correct frame of reference is applied. During deeper analysis of signals associated with Alpha Centauri, there were moments where expected models failed to align with observed output, not in a way that broke science, but in a way that stretched it. The mismatch did not immediately suggest error in observation, nor did it confirm unknown phenomena. It simply created a space where interpretation had to remain open longer than usual. This openness is uncomfortable for structured thinking. The mind wants resolution because uncertainty consumes mental energy. But in advanced research environments, uncertainty is not avoided. It is studied. It is held in place until it reveals either pattern or dismissal. And in that holding phase, perception becomes more refined. Even the most advanced instruments like the James Webb Space Telescope are constantly adjusted to separate meaningful structure from background distortion. This separation is not immediate. It requires repeated calibration, comparison with known references, and elimination of bias introduced by environmental interference. The process itself becomes a form of disciplined attention, where patience is not passive but active refinement. What makes the Alpha Centauri dataset intriguing is not that it provides answers, but that it refuses to settle into simple categories. It behaves like a partially completed equation. Each new layer of analysis adjusts the previous understanding slightly, creating a moving target rather than a fixed conclusion. And in scientific terms, this is often where the most significant discoveries hide, not in what is obvious, but in what resists closure. This resistance forces a different kind of thinking. Instead of asking what something is, researchers begin asking what conditions would produce such behavior. That shift transforms interpretation from identification into reconstruction. It becomes less about labeling reality and more about understanding the mechanisms that shape it. In this way, Alpha Centauri is no longer just a distant system under observation. It becomes a testing ground for perception itself, a reminder that understanding is not passive reception of truth, but active construction of meaning from incomplete inputs. And there is a parallel here that extends beyond science, because human experience often behaves the same way. Life rarely presents fully formed answers. It presents fragments, patterns that do not immediately align, outcomes that require reinterpretation over time, moments that feel incomplete until context slowly reveals their place. The discomfort that arises from this is not a flaw, it is a signal that understanding is still forming. Just like in cosmic analysis, premature conclusions often hide deeper structure that has not yet been integrated into awareness. And when that integration finally occurs, what once seemed random begins to reveal coherence. The most important realization emerging from these observations is that complexity is not a barrier to truth. It is the pathway toward it. The more intricate the signal, the more layers of reality it may contain. And the more patience applied to interpretation, the more refined the final understanding becomes. This is why the early findings around Alpha Centauri continue to hold attention, not because they confirm something extraordinary, but because they resist simplification. They remain open, active, unresolved. And in that unresolved state, they push both science and perception into deeper levels of inquiry. What comes next is not conclusion, but expansion of possibility. When possibility begins to replace conclusion, the entire structure of understanding shifts again. It is no longer about confirming what is real. It becomes about accepting that reality itself may be layered beyond single interpretation. What once felt like uncertainty now starts to behave like depth. And depth always demands a different kind of awareness, one that can hold contradiction without collapsing into confusion. In distant observation work, especially with instruments like the James Webb Space Telescope, there is a constant awareness that every incoming signal is shaped by multiple invisible influences. Radiation fields, gravitational bending, and long-range scattering all combine before any meaningful structure can be identified. This means the final output is never pure. It is always transformed, and transformation is not corruption. It is information passing through layers of reality before becoming readable. This idea alone changes how truth is understood. Because truth is no longer a fixed point waiting to be found. It becomes something that emerges through interaction, through filtering, through repeated alignment of imperfect signals until a stable pattern briefly appears before shifting again. Nothing remains static long enough to be fully owned by interpretation. When attention is directed toward Alpha Centauri, what is being examined is not just a nearby stellar system. It is a dynamic field of changing conditions that cannot be captured in a single frame of understanding. Every measurement reflects a moment that has already passed through transformation. This means what is being studied is always slightly behind what actually exists. That delay creates an interesting psychological effect. The mind tries to stabilize what is inherently unstable. It attempts to convert motion into structure and structure into certainty. But the universe does not prioritize stability in the way human cognition does. It prioritizes evolution, continuous adjustment, constant recalibration of states across time. This is why even small irregularities in incoming data can carry disproportionate weight in scientific interpretation, not because they are necessarily significant on their own, but because they disrupt assumed stability. A single deviation forces the entire model to remain flexible, and flexibility is where deeper understanding begins to form. In many ways, this mirrors how human identity develops. People often assume they are fixed versions of themselves, defined by past experience. But in reality, identity behaves more like a signal being continuously reshaped by new inputs. Every moment adds adjustment. Every experience introduces variation. Nothing remains identical to its previous state, even if change is too subtle to immediately notice. The challenge is that awareness tends to lag behind transformation. Just like light from distant regions arrives after long intervals, self-understanding often arrives after experience has already shifted internal structure. This creates a gap between who someone is becoming and who they believe they still are. And that gap can feel like confusion when in fact it is simply delay in recognition. Scientific analysis of complex cosmic systems operates within a similar gap. Data is collected, but interpretation must wait for refinement. Models are built, then adjusted repeatedly as new layers of correction are applied. No single pass is enough. Meaning emerges only through cycles of revision. And in those cycles, assumptions are gradually replaced by more accurate representations. This is where patience becomes an active form of intelligence, not waiting passively, but maintaining openness while structure continues to evolve. Because premature closure in interpretation often locks understanding into incomplete frameworks. And once locked, those frameworks can distort future perception until they are reopened. The signals associated with Alpha Centauri have contributed to this kind of interpretive discipline, not by providing dramatic revelation, but by requiring sustained attention across uncertain patterns. Some signals align smoothly with known expectations. Others resist classification long enough to demand repeated verification. And between these two states, a more refined understanding slowly forms. This process is not unique to astronomy. It reflects a universal principle of how complexity is handled. Systems, whether cosmic or personal, rarely reveal their full structure immediately. They unfold gradually, revealing coherence only after enough perspective has been accumulated. And that accumulation cannot be rushed without distortion. Even advanced observational systems like the James Webb Space Telescope are designed with this principle in mind. They are not built for instant certainty. They are built for sustained accumulation of refined detail. Each data set becomes part of a larger continuity where meaning is distributed across time rather than concentrated in a single moment. This approach challenges the instinct to define outcomes too early, because early definition often limits what can still emerge. It creates mental boundaries that may not match the actual structure being observed. And when reality exceeds those boundaries, the mismatch is experienced as surprise, even though the limitation was never in reality itself.